That's good. I think we are now streaming. Let me just ask the group, are we streaming? Okay, great. I think we can begin. Um, Everybody, the welcome. We're trying Zoom this time because we have a limit for Google Hangouts. Um, I hope that that's going to work. This will be a test run. We have a lot to go over today, so I'll just jump into it. We also have some new people joining. So the first thing is going to be testing updates. Not sure if Casey or Yoichi or anyone else has any testing updates, but if you do, one of you can go ahead. If not, we can see if Dimitri joins later.
So nothing particular from me. I'm still doing Byzantium cleanup, so the leftover test cases for Byzantium are still being implemented.
Okay, sounds good. So, next we have digital cats cause network congestion. So let's talk about kind of why this happened and some of the proposals around making it not happen again. So the first thing is, why did this happen and what solutions are available? So why did this happen? I think it's just because there were a lot of people sending out transactions for CryptoKitties. What is there anybody who wants to kind of elaborate as like a overview of that?
I mean, from a technical standpoint, it's pretty simple. The gas limit was 6.7 million, and CryptoKitties turned out to be an application that had, like 1 or 2 million gas per block worth of demand, and that pushed usage up. Usage hit the limit. Transaction fees started going up. Then miners upped the gas limit a bit, and it turns out that usage has grown even more, and now we're at an 8 million gas limit, and blocks are basically full. Mm.
Okay, great. Um, the first thing, so subpoint B as the first idea for something that could help with congestion is stateless clients. If you click on B, it'll take you to a comment someone made. Um, Let me see who made that comment.
Is that Alexei Akhuna?
That's
Or
right. Vitalik, I think you talked back and forth with him about that. Do you want to kind of go over that and I guess if it would work? You also wrote a blog post on it, I believe.
Yeah, sure. So basically, like, I kind of have been popularizing the stateless client paradigm a lot lately because that's the direction that I'm going in terms of sharding research. But and for those who aren't aware, the basic idea behind stateless clients is that instead of the client storing the entire state, the client would just store the state root, and it would be the responsibility of either the transaction senders or at least the miner to basically package up along with the block or the transaction the witnesses, which are basically Merkle branches that prove that all of the parts of the state are that the transaction accesses. Um, Now, I did the math on this, and this is theoretically viable, but like in order for it to be really viable, it does require a lot of fairly substantial changes. Basically, because like even after the that we did in Spurious Dragon, the gas costs for updating the gas costs for accessing accounts are just like way too small. So I think the math and I made a reply to Alex's post. Um, let's see if I can just find this right now. But like basically, it's like there's two things that make it hard, right? Well, there's three things that make it hard. The first thing is that arbitrariously is hexary instead of binary. Just from So one of the things that I had suggested in the thread that we at least research is the possibility to access tree nodes in parallel. Um, let's see, database optimization, just bumping up cache sizes. Um, let's see. Yeah, okay. Lofterus commented that it will be really, really nice to do a sync in an HDD. Well, that's pretty much never going to happen until we switch to a stateless client paradigm. Only statedb.commit writes the disk code once per block. Yeah, right. So the one idea that seems possible, well, yeah, there's basically a few ideas in there. Some of them involve hard forks, some of them don't. The ideas that involve hard forks basically have to do with further bumping up the cost of storage reads, and particularly bumping up the cost of storage reads in those cases where they go to contracts that have really big hunks of code. So the ideas that don't require hard forks probably have to do, well, the first thing that we do need to know is like basically how much, what kind of gains can we make from a parallelizing disk reads? Because if those gains are large, then there's a lot of things we can do, including EIP 648, including different kinds of witnesses and so forth. So that seems like something that's really worth looking into. There we go. Here's my comment on stateless client bandwidth. I'll paste that into the awkward dev Skype.
Okay, thank you. Can you all still hear me? Hey, can everyone still hear me?
Yes, Hudson, we can hear you great.
Great, my internet has died, so I'm going to stop everyone's video to help with that, and then I'm also going to try to reset my internet. So I'll move on to the next topic before that then. So does anyone have any comments on what Vitalik just kind of mentioned? So the next comment. Oh, go ahead.
Yes, actually, sorry, it took me a minute to find the unmute. So would this involve us issuing, if we settled on one of these options that was a hard fork, are we talking about doing something specifically for network scaling in the shorter term in terms of forking? Not that we have a plan to do that right now, but were we to settle on that, is that something that we're talking about?
My own opinion is that if there are like low effort things we can do, then we can slate them into Constantinople, and if it's valuable, we can try to make Constantinople slower or smaller and slate it in earlier. Like it basically depends on practice. Like I don't see rationale to like start screaming and boiling our heads off and doing some kind and like doing some kind of emergency change, but like if there's something prudent that we can agree on in the medium term then I think that's totally fine.
Sounds good.
I'd be all for it.
Yeah, so regarding that, there's one thing.
Update from the various clients developers on just like various optimizations that they're doing, whether it's like garbage collection, on disk state caches, like network related stuff, like anything.
Yeah, that's actually, so the next few items are kind of over that with the if there's, sequential disk bandwidth problems and things like that. So before we jump into that, yeah, let's see if since the last meeting or the last few meetings, if there's been significant changes to, like Vitalik said, garbage collection. I know that parity is switching from RocksDB to something else, so if someone can elaborate on that, a few other things. So we'll start with the parity team actually. So if you can just give an update for any client optimizations, things like your database switch, all that.
I'm sorry, my internet. Yeah, Parity is switching to own custom database layer. It's called ParityDB. and I cannot give out any technical details right now. It's on GitHub, you can look into it, but I don't know exactly what's the idea behind. But we are at the limits of what our RocksDB can do, and we tried to fine tune it over the last 6 months, but there's not much room for improvement. So we have to totally switch out the database layer.
Okay, great.
But you created your own database format then?
Yes.
Okay, cool. I'll have to look
Okay.
into that. Anything else, Parody, worth mentioning?
Regarding the database layer or
Oh, just any
synchronization?
any other client updates or optimizations you want to talk about?
No, just in general, we're having a hard time to keep up with the Ethereum main network, and we are working the best we can do to fix any issues as they come up, but it's getting us a hard time.
Okay, no problem. All right, so next, let's go with the Geth team. Peter, I think you're on.
Yep. So I know that Nick's been working on some potential, basically not writing so much out to disk, which should help a bit. But I think he's a bit stuck on an issue. But so that we're trying to. I'm not sure whether Parity. I think Parity is already doing something similar. But the idea is that what we would like to do is to keep maybe the diffs of the last state diffs of the last 100 or so blocks in memory, and maybe write out only every 100th block. And the idea would be that this would raise the memory requirement a bit, but it should reduce disk I/O significantly. It does produce really nice results, or at least did produce a preliminary test, but I think we kind of need a proper implementation before I can give you any details. But maybe perhaps Nick has more infos on it. Other than that, we've also looked at various other databases. Up until now, we also way back we tried RocksDB, and that one didn't produce any noticeable difference for us. We looked at noms, we looked at some Badger DB or whatever it's called. We did up until now we haven't found any, for example, any database replacement that would just automatically solve our problems. We did think about rolling our own database a few times, but we didn't find or have the capacity to do that, and we figured that there are better optimizations to work. So I'm hoping that that we can get Nick's stuff patched up eventually for the next release, and let's see how that performs.
So, Peter, Alexi on the agenda posted very recently that would it be possible to have some optimization improvements if the background miner is disabled? And he said something else about read-write state and from as key value pairs directly, as well as a trie structure, which will require order of magnitude fewer reads. I'm not sure what he means by that, but as far as disabling the miner in the background, would that help?
Yeah, of course, it does help. So disabling the miner in the background, basically, it means disabling the pending state. So currently, whenever a new block arrives, Geth constructs a pending state, basically the next block that it thinks should more or less appear. The only issue is that if some people rely, and some developers do rely on the pending state, then we still have to compute that. So the only way to effectively speed it up for everybody is to drop support for generating the pending. I'm not really sure people would welcome such a drastic.
Sorry, drop support for generating what?
Pending state.
Pending state.
So currently we have a lot of APIs that rely on basically pulling transactions out of the pending state, pulling balances out of the pending state. You can interact with the pending state. That of course means that we are actually processing twice as many blocks because the processing the current block and also generating a new block on top of it. So it's kind of
Is the pending state really that meaningful these days compared to the head state of the chain? Especially since if someone else sends a transaction, it's totally possible that you'll outcompete it on gas price, or that transaction will outcompete you on gas price.
It can be meaningful if one user is sending a series of transactions to a single app.
Right. Okay.
Interact.
But yeah. If it's a series of transactions, it makes sense.
Personally, I don't think the pending state is meaningful because the pending state is limited by the block number anyway. So it means that if you can fit in 100 transactions and there are 4,000 transactions waiting, then basically you get the next 100, which is just a random slice of the pending transactions, and the rest won't make it into the pending state either. So it's not that you get every single transaction currently queued up executed. So in essence, what I'm saying is that personally, I don't see the value in the pending state, but we never wanted to plain simply drop support for it because we don't know who depends on it and where and why. But maybe I'm open to opening an EIP and basically just dropping support for accessing the pending state.
Okay. Any other comments on that, anybody? Great. Vitalik, I'm hearing some scratching in the background. Is it like static on your end?
No idea.
Okay. If you could just mute when you're not talking, then I think it'll be good.
Okay, sure.
Thank you. So next on the agenda, we were going through the clients. CPP Ethereum, any updates or relevant optimizations?
No major updates from us, but we also have some work in progress around refactoring the database layer, and that would allow us to easily change the database too. So we, I think, also plan to experiment with that, maybe do some database optimizations as well. Apart from that, Pavel recently implemented this script to proxy HTTP RPC requests to IPC socket. So that allowed us to get rid of the HTTP server in the client. This theoretically could be used with other clients too. So yeah, I think he continues to improve that. Also, we did some improvements in the command line user interface, and I'm working on improving the experience of downloading and importing the snapshot. I think that's it, yeah.
Okay, thanks. That's good. Ethereum JS, any updates on that?
No updates. Still looking forward to EWAS and testnet. Doing a lot of maintenance and merging open pull requests and stuff in the meantime.
Great. Thanks, Casey. Harmony?
It's interesting fact that Parity has moved from FrogsDB to their own database engine, because we are moving from LevelDB to RocksDB. So we are on the right way to create our own database. So yes. Okay, so we're almost done with that. I need to finalize changes because main scenarios with the database works, and we also had to create new pruning mechanism because old one was based on reference counting, and we got rid of reference counting. So we have to do a couple of tests and benchmarks, and if everything will go okay, then we are releasing next week or the week after the next one at the beginning. So yeah. And after that, we are going to focus on Casper testnet. So that's it.
Awesome. Thanks. And you mentioned at the very first that you're actually switching to RocksDB. Is that right?
Yeah, we are switching to RocksDB.
Okay. Yeah, you might want to talk to Parity if you run into problems, because it sounds like they were having issues with RocksDB. I don't know if there are different implementations, but
I guess they don't have. It's not like they have an issues, but they just got all that they could from RocksDB, and RocksDB is not enough for them, as I understand. So, as I can see so far, RocksDB is okay for us for the Harmony, so we're going with it.
okay, great. Let's see. PyVM.
Yeah, nothing interesting to report. We're just churning away on getting closer to a early alpha release, but same
Great.
work being done, just churning away at it.
Cool. PyEthereum. Vitalik, is PyEthereum worth mentioning at core dev meetings, or is it at a point where it's being moved into PyVM? Oh, Vitalik, I think you still might be muted.
Yeah, sorry. I said not at this point.
Okay, sounds good. I believe that's the last client. So that kind of went over some of the optimizations that we're talking about. And let's see. So if we go back to item 2 and some of the subpoints. Oh, did anyone have
Excuse
anything
me?
else? Yes, Dimitri.
Was there a CPP client report?
Yes, there was a CPP client report. They were doing some database changes.
Yeah, what about tests?
Yes, we actually, testing was item number 1, and no one had any updates really. Could you give us some updates on testing, Dimitri?
Yeah, I'm currently working on changing test source format into YAML. So we now could support test in a YAML format, and in that format we could use multi-line to describe some contracts code, and that would make it easier. We could write Julia, for example, and that should be awesome. You should look at the issue on a test repository, so we could discuss a new test format. Maybe you have some thoughts how to do it properly.
Awesome. So what does this mean for the clients? Are they going to have to do some immediate changes in order to...
Well, nothing, because the final test won't be changed, so it's still JSON. Final test still will be JSON. It's only affecting the test sources. So those who write tests, they could use a YAML, and they could describe a better test with proper comments and multi-line for writing a contract source code.
Okay, great. Anybody have any questions or comments on that? All right. Thanks, Dimitri.
Okay.
So looking here, so I think this might have been, I guess, tangentially discussed by everyone updating their databases, but sub-item D is actually, sorry, we skipped C. Would having minimum system requirements to help set up an optimal client or full node help? Who did that one? Oh, my cat just jumped on my monitor. It went off. Okay, it's back on. Anyways, where is that? Yeah, so just it was RSA management mentioned. If there's like minimum system requirements to set up an optimal client node. hard drive is one of the most important bottlenecks. Okay, that's actually going to go into our next item. So our next item is there a bottleneck not just on disk bandwidth, but on sequential disk bandwidth? And I believe, Vitalik, you commented on that. Was there anything you wanted to add?
Yeah, so basically, I was just wondering, like, whether, so we know, for example, that an SSD read, well, that an SSD can do one SSD read in about 100 microseconds. But in order for an SSD to do 20 SSD reads, where we know what all 20 of the keys are in advance, does that take 2,000 microseconds, or does that take much less than 2,000 microseconds? Because the answer to that question can very significantly impact like what we'd end up doing from a scalability standpoint, both in terms of client implementations and forks.
Any client devs have a comment on that? Like any opinions? So if I understood correctly, have we ran? Were you asking if we've kind of run test for SSDs versus hard drives, or is it a little deeper than that?
No, I'm just asking, are random SSD reads parallelizable? So if you have 20 keys that you want, or like 20 locations that you want to read from an SSD, then first of all, can you do that in less than 20 times the time that it would take in order to just to do a single read? And then if the answer is no, well, that would make me sad. And if the answer is yes, then the follow-up is, well, does that translate kind of going up to the level of like a level DB or some other DB on top of an SSD? And then can that kind of, and then on top of that, like, can that translate into like either doing multiple tree reads in parallel, or ideally some way to do the different parts of the tree read in parallel or something similar?
Okay, it sounds like we don't really know, so that's something that we can look up for next time.
Doing random Google search on it gives back some results that say that usually reading concurrently on an SSD on 16 to 64 threads are quite beneficial, and they can be a lot faster than sequentially reading stuff. So if you are reading multiple stuff from an HDD at the same time, it says that HDD is about twice as fast, and SSD can be 10 to 30 times as fast. Now the question is, of course, so if you are reading and writing these massive database, so these level DB database and others, usually they write out entire blocks, and I think they can pretty much saturate bandwidth pretty nicely on SSDs. Mm-hmm. So in theory, they are fast. In practice, it probably depends on the load, but it's definitely worth an investigation.
Thanks, Peter.
And we also get the benefit that we might be able to do database reads while we do computations, right? So if we know where a transaction loads stuff from, we can preload it into a cache while we process the transaction before that, or something like that.
Okay, so Alexi just commented on the agenda, if anyone wants to refresh their page, and he said that he can do experiments with parallel SSD reads if we want. So I said that'd be great, thanks. So thanks, Alexi. If you can do those and then comment on the next agenda that I'll put up today or tomorrow, that'd be really cool.
So one of the important things to keep in mind is that at least for Go Ethereum, often the block processing time boils down to database writes, write bottlenecks, and, for example, level DB compactions. So if level DB starts compacting and it needs to write out terabytes of compacted data, I'm not sure parallel reads will matter.
So hold on, you're sure that it specifically writes even more than reads that are the bottleneck right now?
I think basically both are the bottlenecks, and LevelDB has this. So the design of LevelDB is to create a stable stream of data, which means that it doesn't give you data back as fast as it can, or it doesn't write out data as fast as it can. Rather, it tries to be stable. So if they're starting to form a write queue, then instead of writing the first 3 items immediately and the last 3 items 1 minute later, it tries to spread out the writes and spread out the reads and throttle them. So whenever you are benchmarking these stuff and you see that there's a big lag on reads or writes, many times it may be simply LevelDB throttling because it's busy doing something else, or just throttling. So it's basically, I'm just saying that it's not trivial to benchmark the thing.
Okay.
Okay.
Great. I think we're good on that. Anybody else have comments? Okay, great. The last subpoint for 2 is Vitalik having some ideas on gas cost changes and scalability relevant client optimizations. We've gone over scalability relevant client optimizations a bit. Vitalik, if you wanted to go over anything else from that comment you left, the gas changes and whatnot.
And I don't think there's anything beyond what's said. Like, basically, the point is that I still think that state reads are underpriced. That's what everything boils down to. And if there were 2 things that I could do to improve Ethereum's, if there were 3 things I could do to improve Ethereum's scalability that are fairly quick, one of them would be to further increase the price of reads, because those are probably still the dominant dust vector. The second thing is something like E648. And the third thing would probably be some the 2 state clearing or account destroying EIPs. I think it was 168 and 169. The dust clearing ones.
And what is what's that EIP you were referring to?
648 is parallelization. And then, if there was a 4th thing, then it would obviously be basically making reads even more expensive and improving the Merkle tree, and then making stateless clients viable. But that would be that's obviously a bit harder to do backwards compatibly.
Okay, got it. Anybody have comments on any of that?
No, well, regarding making reads more expensive, it would be interesting to see how that would actually, what impact that would have on the last period where it's been so full with transaction, and if all those transactions would have taken more gas, or if we could have, we would just have spread out the transaction onto more blocks and made the situation worse, or would the situation have become better? I mean,
I think that in general, right, the purpose of repricing operations is, I think, more to improve the worst case than it is to improve the average case. I think there definitely are ways where we can encourage developers to write their contracts in ways that are better, and we can kind of improve incentivization better. But the more important thing is also, I think, we do have to also be proactive about thinking about the case where there's an actual attack on the network. But I think the risk of an attack is ironically enough less than it was a year ago, mainly because at this point, an attack that even feels like a third of the gas usage would just end up driving transaction fees up to $2 and would burn through $1 million in a few days. But even still, it's worth being concerned about.
Okay, great. Anybody else? Okay, so last thought from me. I think off-chain solutions for CryptoKitties as part of the thing that could help solve, at least for them specifically, some of the scaling issues and some of the network congestion issues. So things like state channels, I've heard that kind of being thrown around as a solution. So I thought that was interesting. So anyone looking at like how to fix the network, it's basically client optimizations, feature scalability improvements like blockchain sharding, and then off-chain solutions like state channels that can be combined with other things to increase increase transactions.
Yeah.
Yeah.
Yeah, I mean, like, I guess I've kind of informally considered like the channel solutions out of scope for the core DevS call because they don't require any consensus layer network layer changes. They're kind of separate networks that are linked to Ethereum, but like that's definitely something that like developers should be holding very close onto their radars.
Cool. Someone on the agenda asked about quantum-resistant cryptography and plans to include it, and I think someone said that account abstraction is necessary.
Yeah, well, okay, technically it's not necessary, but like I personally don't see the point in trying to create one specific quantum proof algorithm. I think we might as well go straight for account abstraction. And we can tell him that like that's already going into Casper. And well, okay, account abstraction going into Casper is for Casper signatures. And then account abstraction for accounts, that actually is something that I did want to bring up because like there was that ETH research thread where we have about 4 or 5 different proposals that I actually think do a better, like a substantially better job than anything we've had before, kind of balancing between having as little complexity on like out of consensus and having as little complexity inside of consensus at the same time. I don't know, Hudson, did you see that ETH research thread yet? And if not, I could try to find it.
Yeah, if you can link that into chat, that'd be great, or into the Zoom meeting or something like that. But and yeah, I think that would be good. Okay, great. Any other comments?
There it is. Hold on. Did I? Yep, I did. Okay.
Cool. All right, I think that covers
I want to
that.
kind of explicitly kind of like actually like ask people to try hard to provide feedback on that over. I mean, like at least the next few days or so. Like it could affect both the sharding roadmap and like it seems like if something sensible gets adopted, it would make sense to feed it into mainline in the medium term as well.
Okay, great. Can someone post this in the Zoom chat? My Getter client crashed. But if someone could post that link in Zoom for those who aren't in the core dev chat, that'd be great. Perfect. Thank you, Martin. Okay. So yeah, people could go and comment on that. That would help a lot. The next item is introducing the KEVM team and K-Viper team. So we have Everett Hildebrandt, and we have, let me find, I just met you this morning. Dejun Park. Yes, thank you guys. So Everett, if you want to just introduce you two and what KVM and K-Viper are and just kind of give a general overview, that'll help us lead into the next discussion, which is a follow-up on the yellow paper.
Okay, can you guys hear me fine?
Yes, we can.
Okay, well, the KVM is a formalization of the Ethereum virtual machine and language that our group works on, which is K. K is kind of a operational semantics framework that ends up giving you a bunch of software development tools once you've specified your language's definition in K. So what we did is just formalize the EVM following the yellow paper almost directly, and when we were confused, we looked at source code in the various clients But yeah, and then now we have even branches, I think, for the Byzantium update, although there's a bunch of unmerged branches in the K repo right now because we've all been kind of busy with school stuff, just end of semester things and wrapping all that up. But more recently, we've been looking into supporting some higher level languages. So back over the summer, there was kind of some experimental prototypes in that direction, just extending the EVM with some high level languages. And more recently, Dejun has been leading efforts on making semantics for Viper. Well, maybe not leading the direct semantics efforts, but he's certainly working a lot on the semantics of Viper, which we originally gave semantics in terms of a translation to EVM. So maybe Dejun can talk a little bit about that real quick.
Yeah. Do you hear me?
Yes.
Oh, so yeah. So yeah, I'd like to quickly talk about our project for the Viper. So our goal is to provide some formal tools for the Viper language. So as a first step, we formalize the language semantics on the top of the K EVM. Specifically, we formalized actually the Viper compilation itself. So roughly speaking, you can think about this as a translating Python implementation of the Viper compiler into some mathematical definition in K. So which means that we kind of yet another compiler, a Viper compiler, so that we can cross-check each other to test them. As a good side effect, actually, we found some bugs in the production compiler, also help to improve some design of the language by proposing some new features. So based on this, the formal semantics, we are right now working on two tools, the formal tools. One is the verifier for the Viper programs, and another is verifier for the Viper compiler itself. So let me introduce a little bit details about these tools. So the first Viper, program verifier for the Viper programs is that we have the core engine for the verification, but we'd like to make it more usable and easy to use by the contract developers. So we are thinking to provide some annotation language features into the Viper programs so that the contract developers can describe their intention of their contract into their source code. And then we can take the source code and annotation and verify the properties satisfied by the contract programs. So right now we are using the ERC20 token implementations by Philips as a test bed for our verifier. But once we have done this, we are thinking to move on to verify the task per contract as Vitalik proposed. That's the program verifier idea. For the verifier for the compiler, so we also have in K a kind of program equivalence checker, which means that which takes two programs and checks that they are equivalent or not. So using this program equivalence checker, actually we can verify that the Viper programs and the EVM program compiled down to from the Viper, we can verify two programs are equal or not, which means that you can actually verify the compiler is correct for each instance of compilation. Another application of using the program equivalence checker is that suppose you want to migrate Solidity contract into Viper, then you want to make sure that actually the Viper programs actually equivalent with the Solidity one. So what we can do is that we take two EVM bytecodes, each generate from the each language, and then you can actually verify that two EVM programs equivalent, which means that you correctly migrated the original Solidity programs. So that's the compiler verification idea. Mm-hmm. So yeah, we are working on this too, and then hoping to finish in a short term. Actually, we released. Actually, Philip posted the link to that. So Philip write off the blog post about this, what we've done, and we are we're thinking to plan to do. So yeah, please check it out. Our plan.
All right, thank you so much for the intro there. Anybody have any comments on KEVM or any of the other stuff?
It's also worth noting, and let me put a link to this in the chat, so maybe someone can forward it to the Skype channels. We also have essentially from KEVM this compilation to a web-based and human-readable, hopefully eventually, documentation of the KEVM semantics. So we're kind of calling this like the Jello paper. It's meant to be sort of like the yellow paper, except that it can be fully compiled into an implementation for EVM. Right now, it's like sort of early stages. It was compiled directly from the existing version of the KEVM semantics.
Did he just cut out?
No, we can still hear Phil.
It's your internet, Everett. Anyway, so the idea is essentially to be able to compile this Jello paper into a full implementation of the EVM that could even potentially be used in a client one day. Unfortunately, right now, it's sort of compiled from the semantics that we've mainly written for the paper and for our own tools. So maybe for those who don't have a good familiarity with K, it might be a little bit difficult to read. But we're hoping to get input and continue to refine it until it's completely human readable and also a complete executable specification.
Awesome. That's great news. And Phil, sorry, I didn't even introduce you. If you want to do just a couple sentence intro.
Sure. So I guess I'll give some background on the KEVM project while I do that. The KEVM project is split across two entities right now, which is the University of Illinois, where Professor Grigory Roshu is a professor and has a research lab that works on formal semantics, and also the spin-out startup Runtime Verification, Inc., which is intended to commercialize the technologies developed by Grigory's lab. So I'm kind of the head of smart contract strategy at RV, which is like the commercial side of the collaboration. And I'm also a PhD student at Cornell at IC3.
Great. Cool. Anyone have any comments on all that? It sounds like a lot of cool stuff going on. Okay, great. So the next item is a follow-up to what we talked about last time. There's a link to does it remain the case that the yellow paper is intended to be Ethereum's formal specification? That was initially brought up by Ben Edgington. So we have Ben Edgington in here today as well as Daniel Ellison. They're from Pegasus, which is Consensus core client team. So actually, I'll let Daniel and Ben introduce themselves. Daniel, if you want to go first, and then Ben, if you want to just quick intro, and if you want to mention what Pegasus is, if I didn't explain it correctly.
Okay, hi everyone. I'm Dan Ellison. I've met some of you before. I work at Consensus. Just to clarify, I'm not currently on the Pegasus team, but I'm doing a lot of language research, and as people like Axec know, I've been trying to revive LLL, which is actually working out quite well. My interest here is languages, so that's me.
Great, thanks. Ben?
Hi everybody, so my name's Ben Edgington. I'm in the Pegasus team within Consensus. So Pegasus means Protocol Engineering and Systems. We're a relatively new team, but we're focusing on core blockchain protocols, research and development. Of course, at the moment, it's fully focused on Ethereum. Slight emphasis on private Ethereum networks, but definitely intention is to span the whole space and be very active in the public Ethereum space as well. So I'm in the research and development part of Pegasus.
Awesome. Thanks, Ben. So now back to the topic about the yellow paper being the formal specification. Anyone who's talked to, I don't see Gavin in here today, but is anyone here who was sent by Gavin to speak about the yellow paper, or who has gotten a response to Gav with respect to the yellow paper comments from last time? Or the licensing of the yellow paper?
Yeah, I reached out to and he said he's happy to put the yellow paper repository under a Creative Commons license. So far, he didn't do it yet because he's busy. So he's currently considering which CC license. So, but if anyone wants to help to figure out, just reach out to him. He said he will be able to do it in around 2 weeks. So that's the status for now.
Awesome, that's a good update. So basically, Ben brought this up last time and we went through this, but basically the questions are, does it need to remain the formal specification? And if not, what replaces it? I kind of want to throw in a third option. Does there only have to be one as long as they're compatible with each other? I'm not versed in how these type of formal specifications for this stuff needs to go down, but can anyone answer the question? Is there a possibility of interoperability?
So maybe I can say a couple words about that. The KVM is testable and executable. So if you had another executable or testable specification, you could check interoperability of those two, or you could check agreement of those two specifications. But I don't see a way to mechanically check conformance of the yellow paper with other executable specifications. Certainly, though, could try to kind of get a merge of the two, because the yellow paper has a lot of useful English prose and other high-level overviews of the EVM that help implementers and certainly helped our team implement the KVM. So I think what Philip was saying earlier makes a bit of sense. Essentially, have an executable specification that also is human readable. Now, I think K itself is human readable, but I don't know if other people think so. So I think it's probably best to kind of get more English prose style stuff in there for people to get a better overview of the whole thing at once.
Yeah, I agree. And I don't think it's necessarily a bad thing to have multiple specifications, especially if client developers are aware of that. But you also don't want to fragment efforts too much. Like, it is nice to have a very small number so they can all still be audited and checked very thoroughly every time they're updated.
I know at one time Gavin had a yellow paper committee that dealt with the responsibility of keeping the yellow paper updated. I'm not sure what the status is on that. Maybe we can talk to Gavin if he can attend the next core dev call, or just offline or off call talk to him about it. But I think something like that in a at least communication between KVM and the yellow paper would be good. Now for general discussion about this, anybody have any thoughts on if it should remain the formal spec or anything else about what we've been discussing?
We are running a public protocol, so an open license is kind of really, really important. It's a bit surprising the yellow paper hasn't been licensed. So I believe that's the first step for the yellow paper side. On KEVM, so I was reading the master branch of KEVM for a while, and the Byzantium changes hasn't hit the master branch yet. So, and yes, in some cases, the English paragraphs are very short. They look like comments to the code. So there's some work to do, but KVM has already got a good license. So people can work together to make it better already.
Okay, great. So it kind of just sounds like the destiny of the yellow paper is up to a certain extent to the yellow paper creators, and whether or not it's licensed. And I agree with you. That's a good first step. Anybody else have comments?
Yeah, we'd love, of course, to also move KEVM to more like foundation ownership. So, the domain, the repo, whatever. I mean, if you guys want to take control of some of that, it's an open offer pretty much.
Cool. I can hook you up with some people to talk to about that, since on these calls I don't represent the foundation. But I think Vitalik and other people would love to help with something like that.
On the other hand, if this EVM semantics is still in the K-framework organization, then every time the K framework itself is upgraded, you guys will be fixing the syntax and so on, and that's a nice thing. But I mean, it's a small thing compared to the whole other.
Yeah, we have enough efforts that rely on KVM now that we'd probably do that no matter where it lived.
All right, thank you.
Anybody else have comments?
Yeah, the other cool thing about the KEVM is that it actually they said it was an executable spec. Maybe it was already mentioned that it actually runs and passes all the state tests. Well, maybe not all of them, but certainly close to being able to pass them all. So in the same way that every other client runs and passes those test cases, the KEVM spec can do that as well.
Yeah, you can even also use it to potentially generate test cases. So eventually it could even, if it was desirable, replace something like CPP Ethereum for that job.
I would love to see that happen. No offense to CPP Ethereum, but seeing the test cases generated by the spec versus just one of the implementations would make me a lot more confident that CPP Ethereum wasn't the actual spec.
Yeah, that's sort of the argument that was made in the KVM paper, that the yellow paper is like the human readable spec, but CPP Ethereum right now is the actual machine implementable spec.
Okay, cool. Let me see. Is Dimitri actually dropped off? I was hoping he could comment on this, but we'll have to wait till next time. Okay. Anybody else have comments? So in summary, the yellow paper, there needs to be some changes over the next month. Gavin needs to communicate what the license changes are going to be and the steps starting for that. And then hopefully from there can be some communication between KVM and the yellow paper, the maintainers of the yellow paper, so that there can be some coordination going forward. It sounds like the KVM is going to be going full steam ahead, and that sounds really cool as well. Really exciting project, guys. Thanks for coming on. So I think
thanks for having us.
I think that the next item is going to be. So I don't know if there's any official statement today, but if Afri, did you want to talk about the parity ether proposal or Yuta? I didn't know if that needs to be brought up next time after there's more research and more finalization of some of the ideas.
Actually, I don't want to talk about it except for one comment, maybe, that we at Parity don't really want to follow up on the proposals because we hear the feedback is clear and loud, and so we are not putting any more efforts into improving or updating these proposals, and yeah, that's it basically right now.
Okay, great, and I'm sure there'll be like a formal declaration or even informal declaration outside of the call. But thanks for mentioning that, Afri. Okay, great. We can go on to the next one then. The proof of authority testnet unification. Is there any updates, Piper? I just leave this in here every time, but if there's not, that's okay.
No, there's no updates right now. Nothing right now.
Cool. And we've already gone over the core team updates, so we actually got through this real quick, guys. We're 15 minutes before our hour and a half mark. Does anybody have any other comments, questions, agenda items they want to bring up that were not included in the agenda? Okay, great. So thank you everybody for joining. Let's actually look at this. 2 weeks from now is the 29th. That should work. Is there any? That's almost New Year's, but who's like taking off on the 29th? Does anybody?
I won't be anywhere near internet if you want me there.
Anybody else? As long as there's a majority of people, I think we'll keep the meeting on.
Would it make sense to postpone it 1 week? It's a bit weird.
I guess I couldn't decide like who would be online during that, but we can definitely postpone it if we want.
Well,
let's push out
a meeting on the 29 is.
Sorry, say that for, Piper. You can speak first.
Yeah, I was just saying, unless there's a reason that we need to have it in 2 weeks, let's just push it down more week to get it out of the middle of that holiday block.
Yeah, I agree. Let's bring this to the Skype and Gitter channels, and then I will announce it in the agenda that I post on there, but we'll definitely delay by at least a week, if not 2 weeks, because a week after that is the 5th, and people will still be kind of getting back into the swing of things, so we might do 2 delays. Is anyone opposed to doing a 2-week delay rather than a 1-week delay? That's good. I think we are now streaming. Let me just ask the group, are we streaming? Okay, great. I think we can begin. Everybody, welcome. We're trying Zoom this time because we have a limit for Google Hangouts. I hope that that's going to work. This will be a test run. We have a lot to go over today, so I'll just jump into it. We also have some... That's good. I think we are now streaming. Let me just ask the group, are we streaming? Okay, great. I think we can begin. Everybody, welcome. We're trying Zoom this time because we have a limit for Google Hangouts. I hope that that's going to work. This will be a test run. We have a lot to go over today, so I'll just jump into it. We also have some new people joining. So the first thing is going to be testing updates. I'm not sure if Casey or Yoichi or anyone else has any testing updates, but if you do, one of you can go ahead. If not, we can see if Dimitri joins later.
So nothing particular from me. I'm still doing Byzantium cleanup, so the leftover test cases for Byzantium are still being implemented.
Okay, sounds good. So, next we have digital cats cause network congestion. So let's talk about kind of why this happened and some of the proposals around making it not happen again. So the first thing is, why did this happen and what solutions are available? So why did this happen? I think it's just because there were a lot of people sending out transactions for CryptoKitties. Is there anybody who wants to kind of elaborate as like an overview of that?